This is 2019 Prelim, Pure Chemistry, Bukit Panjang Government High, Set 5. For question number 6, on heating 0.02 mole of element M reacts with 0.05 mole of oxygen gas. So you need to find the empirical formula of the oxide of M. That means M oxide, for example, sodium oxide. So when you are finding the empirical formula, you need to find out how many mole of M combines with how many mole of oxygen atoms. Okay, so this it should not be oxygen gas, it must be, you have to find out oxygen atom. So in this case, 0.025 mole of oxygen gas O2. So you need to find out how many mole of oxygen atom. Okay, so 1 mole of oxygen gas has 2 mole of oxygen atoms. So 0.025 mole of oxygen gas should have 0.025 times 2, which is 0.05 mole of oxygen. And for so you have M, okay, empirical formula, the table. So 0.02, so this will be 0.05. So which means 2 mole of M combines with 5 mole of oxygen. So you have M2O5. That's why the answer is C. Question 25. Okay, carry out an experiment. Find out the identity of an unknown salt, Q. Okay, that contains either 1 of or 2 N ions. You need to find out the N ions, 1 or 2. So she added reagent P slowly to the salt. So you can see that when reagent P is added to the salt, right, a precipitate is formed, followed by addition of dilute hydrochloric acid. When hydrochloric acid is added, the mass of precipitate drops, but it doesn't go to 0, which means that there must be 2 types of precipitate. One of the precipitate reacts with dilute hydrochloric acid, and then the other one doesn't react with dilute hydrochloric acid. So there must be 2 anions. Okay, and both the anions actually form precipitate with reagent P. And out of the 2 precipitates, one of the precipitates reacts with acid. So if you look at the option, so there should be 2 precipitates that form with between a reagent P and Q. Okay, let's look at A, barium chloride and chloride. So no precipitate is formed. Okay, then for B, barium chloride and carbonate. Yes, the precipitate will be formed, that is barium carbonate. Barium carbonate is the precipitate, but then there is only 1 precipitate. So over here, there must be 2 precipitate. One of the precipitate reacts with acid, the other one doesn't. So if you look at C, silver nitrate, yeah, so it will form silver chloride as well as silver carbonate. So both are precipitates. And one of these precipitates must react with acid. So in this case, your silver carbonate reacts with acid. All right. And then the other precipitate doesn't react with acid. So the answer is C. Question 29. Okay, 2 substances are added together in a chemical reaction. Was surprised that the reaction allows him to identify the cations. So both the substances, the cations, are able to be identified. Which of the following is a correct pair of substances that he used? Let's look at A. Iron 3 chloride and sodium hydroxide. So if you add these 2 together, you get iron 3 hydroxide, which is a reddish brown precipitate. So the reddish brown precipitate allows us to identify the iron 3, but not the sodium. Yeah, because how do you identify sodium? There is no particular test to allow us to identify the sodium ion. If you use aqueous potassium hydroxide, you will get the same result. You still get iron 3 hydroxide, which is reddish brown precipitate. So there is no way that enable us to, in this test, the sodium ion cannot be identified. How about for B? Copper 2 carbonate and dilute hydrochloric acid. Now, the cation here is hydrogen ion, and the cation here is copper 2. So when these 2 substances are added together, you get copper 2 chloride, which is a blue solution. So the blue solution allow us to identify the copper 2 ion, and also when these 2 substances are added together, you get you get carbon dioxide gas. And the fact that carbon dioxide gas is released allow us to identify that there is hydrogen ion present. So the hydrogen ion, the H plus, is identified, the CO2 plus is identified. Now, how about C? Zinc chloride and barium nitrate. So if you add these two substances together, actually no visible reaction. Yeah, why? Because zinc nitrate is soluble and barium chloride is also soluble. So basically, when you add these two together, you don't get any new substances formed. The barium nitrate, chloride, and zinc ion will just be floating around. How about for D? Calcium nitrate and aqueous ammonia. So from the QA, you should know that when calcium ion is added to aqueous ammonia, no precipitate is formed. So there is no visible reaction for calcium nitrate. Question 30. The apparatus shown in the figure below can be used to investigate the gaseous products of combustion. Okay, when propane is burned at position X, anhydrous copper 2 sulfate turn blue. So anhydrous copper 2 sulfate, original color is white. When it turns blue, it means that it becomes hydrated. That means moisture or water has been absorbed by anhydrous copper 2 sulfate. So it will absorb the moisture. So when propane burns, the products are carbon dioxide and water vapor. So the water vapor would be absorbed by the anhydrous copper 2 sulfate, and then the carbon dioxide will be bubbled into the lime water. So whatever that comes out here will not have carbon dioxide. So if you look at the answer, A is out. Now, how about hydrogen? Is there any hydrogen in the air? There is no hydrogen in the air, so it's out as well. A, B, C are out, so the answer is D. Let's look at D, mixture of nitrogen, because air, 78% of the air consists of nitrogen, so there will be nitrogen coming out from A. So nitrogen will not be absorbed by the anhydrous copper 2 sulfate or the lime water. And how about carbon monoxide? Yeah, there will be some carbon monoxide formed here, because even though this is an open space, when you combust propane, the oxygen here may not have enough time to get here to allow complete combustion. So there might be some incomplete combustion taking place here. Yeah, that's why carbon monoxide is released, carbon monoxide is formed, and there will be some carbon monoxide in mixture A. Question 32. Which of the following compounds could be formed by the action of bromine on an alkene of the formula C4H10? So this is actually addition of bromine or bromination. Yeah, now you need to know that if alkene, it's when a bromine is added to alkene, the bromine atoms will be added to the two carbon atoms sharing the carbon-carbon double bond. So for example, this is ethene, right? So you add bromine to ethene. So this is a compound form, and take note, the bromine atoms is added to the carbon atoms sharing the carbon-carbon double bond. So it will not be in such a case whereby both bromine atoms are added to the same carbon atom here. Okay, so this is the only possibility. Now, how about this? This one, it will not happen because the two carbon atoms having the carbon-carbon double bond must be adjacent to each other. So this is not adjacent, not next to each other. Now, likewise, so this is similar to this, whereby the bromine atoms are added to the one single carbon atom, which is not possible. Question 35. Isomers having the highest boiling point. When you see a bracket here, that means these are the side chain. So A is a branched chain isomer. Now, what do you mean by that? If I draw out the structural formula, it would be like this. Okay, for A, C, it has 3 branch chains or 3 side chains. And then CH2, CH3. That's for A. So if you look at B, it has 2 side chains. D, it has 1 side chain. C is a straight chain. There is no side chain as well. So C is a straight chain isomer. Now, what's the difference in terms of branched chain and straight chain isomer in terms of the boiling point? Now, side chain isomer, the boiling point is lower. Now, why? Because the intermolecular attraction forces. So if let's say I have another such molecule, right? The intermolecular attraction forces between these two molecules is weaker. Now, why is it so? Because the intermolecular attraction forces is between the proton and the electrons. So when you have such a situation whereby there is a side chain, there is a shielding effect on the intermolecular attraction forces. That means the attraction forces between, let's say, the protons of this carbon atom and the protons of this and the electrons of this carbon atom. The attraction forces is shielded by this branch chain. Yeah, so there is a shielding effect of the attraction between the protons and the electrons. That's why the intermolecular attraction forces tend to be lower for isomers with side chains. For straight chain, it is very straightforward. There is no shielding because there is no side chain. So the intermolecular attraction forces is stronger. Hence, straight chain isomers tend to have a higher boiling point. Okay, stronger intermolecular attraction forces and hence higher boiling points. Question 37. So you need to find out the number of double bonds. In this case, it's actually carbon-carbon double bonds. So 10 grams of the hydrocarbon, MR80. So 10 divided by 80, that will give you the number of mole of the hydrocarbon, which is 0.125. And then it requires 9 dm cube of hydrogen. So hydrogen is a gas. So 9 dm cube, if you divide by 24 dm cube, that will give you the number of mole of hydrogen gas, which is 0.375. So at this point, we know the ratio between the mole ratio of the hydrocarbon to hydrogen is 0.125 to 0.375, which is 1:3. So 1 mole of the hydrocarbon, 3 mole of hydrogen, which means 1 molecule of hydrocarbon requires 3 molecules of hydrogen for complete hydrogenation. And you should know that each carbon-carbon double bond would require one hydrogen molecule to break the carbon-carbon double bond and the hydrogen added to it. One carbon-carbon double bond requires one hydrogen molecule. So if, let's say, the hydrocarbon requires 3 hydrogen molecules for complete hydrogenation, it actually implies that the hydrocarbon molecule must contain 3 carbon-carbon double bonds. So this one is 2 carbon-carbon double bond, cannot. So this one also 2, and this one is 1, 2, 3. There are 3 carbon-carbon double bonds. So one of this molecule would requires 3 hydrogen molecules to break the carbon-carbon double bond and the hydrogen atom added to it. Right? This is actually wrong because each carbon should share 4 pairs of electrons. So this one is 5 pairs. So therefore the answer is C.